Okay, next, we shall look at link state dynamic routing protocol. Okay, link state routing protocol, sometimes we call it the shortest path first protocol. It was built around the shortest path algorithm that was created by this person. Sorry, I don't really know how to pronounce his name. Okay, the different type of link state routing protocol includes OSPF, Open Shortest Path First, and IIS, Intermediate System to Intermediate System. We will not cover IIS, so in our module we will only cover OSPF. So all the link state routing protocol will use this shortest path first algorithm, and this algorithm is used to calculate the best path. And how do they calculate the best path? They will use the cost. The one with the lowest cost will have the best path. And the cost is the accumulated cost along the path, from the source to the destination. For example, in this case for R2 to reach the destination, this network, the path will be 20 plus 5 plus 2. So total of 27. And also each router will determine its own cost to the destination in the topology. Unlike previously the distant vector routing protocol, the router will take the neighbor cost or matrix and add to it. But in this case, no, each router will determine its own. They will not take any values from the neighbors. Okay, let's look at one of the example. Okay, let's look at R4. Okay, for R4, this table will show the shortest path to the respective local area network. Okay, so we have the R1 network, R2 network, R5 network, and the R3 network. Okay, look at R1 network. So for R1 network, which is over here, there's a few ways to go. One way is to go through here. The other way is to go through here. The third way is to go one round here. So 3 ways to reach the R1 network over here. So which one is the shortest path? Okay, so by going this way, the accumulated cost is 22. By going the second way, the accumulated cost is 17. Okay, 10 plus 5 plus 2. By going the other way via R5 will be 10 plus 10, 20 plus 20 will be 40 plus another 2 will be 42. So the best path is to go through R4, R3, R1. And because this gives you lowest cost of 17. So similarly, by running this shortest path algorithm, R4 is able to calculate the shortest path to go to R2, which is via R4, R5, R2, and then up here, shortest path to the R3 LAN, and the shortest path to the R5 LAN. Okay, the path and the cost, and this will be the lowest cost as compared to the other path. Okay, some characteristics of the link state routing protocol process. Okay, so every router will learn about its own directly connected network first. And then they will try to find its neighbor by sending a hello packet to its neighbor on the directly connected network. So he gets to know all the neighbors that is directly connected to the router. Then the router will build a link state packet of the state of each of the directly connected links. So if the router got 3 links that is directly connected to it, it will create 3 link state packet. And the link state packet will contain the state of each of the link. Okay, so with this 3 link state packet, he will flood the link state packet, the 3 link state packet to all the neighbors. Okay, and then the neighbors will store the link state packet in the database. At the same time, that router will also receive the link state packet of the neighbors also. The neighbors will also flood their own link state packet, and then this router will also receive the link state packet. So at steady state, every router in the network will have the link state packet of every other routers, including himself. And then their database of all the routers will be consistent. They will have the same database. And then once they determine that the database has stabilized, which is converged, they will use the database to construct a complete map of the topology. So every router will construct the same map. And then each of the router will compute the best path to the remote destination network. Okay, so the process will be the same for version 4 and version 6 in both OSPF. Okay, let's look at the process in detail. Okay, using this topology, we'll look from the R1. Okay, look from the view of R1. Okay, the first step of R1 is to learn about its own directly connected network. So R1 got this network 10.1.0.0/16. Okay, the IP address of this interface that's connected to R1. This is an Ethernet interface. The cost of Ethernet is 2. And there's no neighbors. There's no routers connected here. So there's no neighbors. So this is a link state packet for the first directly connected link. Then router R1 will continue to build the link state packet for link number 2, link number 3, and link number 4, filling in the information. Okay. And so he will build 1, 2, 3, 4, 4 link state packets. Okay, the second step of the link state process is that the router will try to find the neighbors on this directly connected link. So he will send the hello packets, okay, including here. So when he sends the hello packet out, here he did not receive any hello packet, so there's no neighbor here. Over here, he received a hello packet from R2. Here he received a hello packet from R3. Here he received it from R4. So R1 know that these are the neighbors that is connected to his directly connected link. Okay. So the hello packet are sent periodically. So if the router did not receive the hello packet from a neighbor, okay, if he stopped receiving it, then he will presume that the neighbor is considered unreachable. It's considered dead. So this is considered keep alive mechanism. The third step of this link state routing process is the router will build a link state packet containing the state information. So there will be a link state packet for this link. Okay, we'll show you an example in the first, in the slide how they created the link state packet. So this will be an Ethernet network. Then this will be the network address, and the cost is 2. Similarly, it will build the link state packet for here. Okay, which is connected to R2. It's a serial point-to-point link. Cost is 20. This is the network that is for this serial link. Okay, he also built the link state packet for this link, the link between R1 and R3, and also the link for R1 to R4. So there will be 4 link state packet, and it's ready to send it to the neighbors. So the fourth step in the link state routing process is that the router will flood the link state packet the link state packet, okay, to all the neighbors. Okay. Similarly, R2 will also flood his link state packet of his directly connected link to all the neighbors. Similarly for R3, for R4 and R5. So they will flood their link state packet to all the routers. And the link state packet will only be sent during the initial startup. After that, no more sending. Until there's a change, then they'll flood the link state packet again. Okay. Otherwise, they will not send the link state packet if everything is going smoothly. So the link state packet also contains a sequence number and the aging information. This is used to check, okay, for the router to check the sequence number. If it is the same, that means it's already received the same link state packet. He will discard it. If it's different, that means it's an updated one. Then they will use the updated one and replace the old link state packet in the database. Okay, so this link state packet created by R1 will be flooded to all the routers. So all other routers will also create their own link state packet and send it to the other neighbors. Okay, the final step in the link state routing process is that each router will use the database. Okay, this database, okay, to create a complete map of the topology. So every routers will have the same information in their database. This is the link state database for R1. R2 will also have exactly the same link state database. So they will create the same topology between R1, R2, R3, and R4 and R5. Using this information, they can start to create the map and compute the best path. Okay. Once they create the map, they can start to compute the best path by calculating the cost. So remember in the earlier slide, we show you how does R4 calculate the cost to go to the R1 network. So every router will do the same to calculate the cost to the remote networks. And then with the path that have the lowest cost, they will insert that path to the routing table. So how do they calculate the shortest path? They run the shortest path algorithm. Okay, so this is a step. They use the database, run the shortest path algorithm, construct the map. Okay, then they will identify its own directly connected network, R1, the cost. They will add the remote networks and the associated cost all in the table, and then they will run the shortest path first to find the shortest path, and then they will have the shortest path, okay, in the table. So each router will construct its own shortest path. They will not work together with other routers. Once they have the table that's shown in the earlier slide, okay, they will construct their own shortest path independently. Okay, and finally, with the shortest path information determined by the shortest path algorithm, this path will be added to the routing table. Together with the static route, directly connected route, all will be added to the routing table, and now the router will know how to route packet to all the remote network, okay, to its own directly connected network and also the remote network using the shortest path algorithm. Okay, what are some of the advantages of using link state routing protocol? First is every router uses its own topology table or topology map to calculate the shortest path, because every router you have the same topology map and then they use the same map to calculate the shortest path. Normally the path will be very accurate. Okay, so the path that they determine is very accurate because it's based on the entire topology table. Okay, second advantage is the immediate flooding of the link state packet will achieve faster conversion. That's why link state routing protocol can be used for a bigger network. Okay, because every router, when he receives the packet, they will immediately flood the link state update to other routers. They will not do any processing. So the immediate flooding allowed the router to quickly achieve convergence so that every router has the same link state database. Okay, the third advantage is link state packets are only sent when there's a change in the topology, and it only contain information about that change. Unlike RIP, remember RIP send the entire routing table to the neighbors, okay, periodically. So, but link state routing protocol like OSPF, they only send the link state updates when there's a change, and in the update you only contain information about the change. Okay, and lastly, if the network becomes too big, we can apply hierarchical design, multi-area OSPF, okay, to make your area smaller. Okay, so that your flooding will not go too big. Okay, excessive flooding of link state packet, although it has its advantage, you achieve convergence, it may also eat up a lot of bandwidth. So you can use hierarchical design and run multi-area OSPF, which will also cover, okay, when you go to OSPF. Disadvantage of link state routing protocol. Okay, link state routing protocol generally require more memory, more processing, CPU processing, because they store the entire topology inside the link state database, and they also run shortest path first on the topology to calculate the best path. So you require more memory, more CPU as compared to distant vector. And also the initial flooding during cold start, initial flooding of the link state packet may also affect the bandwidth to send the real data. Okay, to help to reduce the requirements, we can run multi-area OSPF. We can help to reduce the size and also reduce the memory and processing requirement. We'll look at multi-area OSPF when we go to that chapter on multi-area OSPF. Okay, the two types of link state routing protocol are OSPF and IIS. We will not look at IIS because it's mainly used by ISP. In our module, we will look at OSPF version 2 for IPv4 network. Version 3 was created for IPv6 network. Okay, that's all for this chapter